All right. This is it. Own this one in 2D, and it's this straightforward. I'm just going to put the vectors on the page. I'm not going to put any units to them, nothing. Just going to put vectors on the page. There's a vector. Call that vector 1. There's a vector, Victor. There's a second vector. There is a third vector. You can add as many as you want. How do you do it? You pick off 2 at a time. It makes the most sense to pick out ones that work the best. And in fact, if you think about it, this is a worthless problem because they're all concurrent. We'll do it anyway. They all seem to be concurrent forces, and so I can slide this one up along its line of force. When I do that, get rid of the one you just got rid of. I can slide this one over, and I can slide this one up. What's the fun of that? They're all concurrent about a point. You can do this, and then you can do that, and you have the result. Those were what? Concurrent force vectors, because I was too crazy and lazy to draft non-concurrent forces. Remember that any 2 coplanar vectors are concurrent. So when we add 1, there's a vector. There is a vector. Here's a third vector that is not concurrent to the other 2. You work them 2 at a time. You get awfully good at about getting rid of what's behind you with either a squiggly bat or an eraser or layering. But let's pick this one. I take my lines of force. I find a point of concurrency. I learn to slide up along here with a divider. And so that becomes, for my point of concurrency, my force. In other words, that force was this force. This one is no longer here. That one gets slid up. You do this with a divider. This is no longer here. You add these vectors tip to tail. You run out of paper, but you do it by sliding it over. That is your resultant right there. That is your resultant. So what you got left now is 2 vectors, this vector and that vector. You then have to slide them to their point of concurrency. You slide this down. You go ahead and slide this one down, and then you add them together. That becomes your resultant. This one here, the rest of them are not there. Realize that any force along this line of force, any force along that line of force will be equal in terms of its moment about any point in space. Later on, you're going to find out it is important to eventually put everything back, but I have to know where everything is for me to put it back. I'll do this slower the next time, but I want to push this one out so you can see it. Remember, you work them 2 at a time. The steps: pick 2 vectors, find their point of concurrency, slide each vector so its tail emits from that point of concurrency. Then add the vectors tip to tail, come up with the resultant. Get rid of everything except the resultant, and then start again. Take the resultant and the line of force of another vector, find the point of concurrency, slide the resultant back down. Everything should emit its tail from the point of concurrency, and then add them tip to tail. You do this quick, fast, with triangles, and you can get a lot done. Thanks for listening. That's 3 minutes and 30 seconds. Wish I'd done this before.